What's up mga ka-ChE? It's Kaydale here and I'm back with another chemical engineering principles lesson, but now we are moving on to the major part of a chemical engineering. It's actually the heart of chemical engineering, which is unit operations. Okay, unit operations, and the first topic that we will tackle under unit operation is evaporation. Okay, so it's evaporation, and I have prepared questions for you for us to answer this time. Okay, for us to answer this time, and um, I'm still using this. Okay, I'm still using this reviewer. Okay, for chemical engineering licensure examination, third edition by the Manila Review Institute. Yeah. Okay, so now that we've got that out of the way na, so let's start. So I think I'll be answering a few whatever the time that we will have, maybe 30 minutes. Okay, so for this time, okay, for this video, so let's begin our lesson. Okay, for this time, diba? So we are now at evaporation. Okay, yeah. So the first question. Okay, the first question. Let's get right to the point. Diba? The pressure in the evaporator chamber is decreased. Diba? Boiling point. If pressure and temperature are directly proportional. So if you lower the pressure, syempre, the boiling point of the solution also will decrease. So it's concentration of glycerin for water solution by the application of heat is, of course, what are we talking about? Is evaporation, diba? So number 3, two evaporator flow configurations needs fluid motive devices to transfer solution from one effect to the other effect. Fluid motive means you have to use a pump, diba, to move the liquid. So what do you have to use? That would be the configuration that needs a pump is that if you have a difference in pressures, and if uh, you can't supply it to another if the other effect from a lower effect to a higher one, the pressure, diba? So meaning it has to be backward flow, yeah. So I know you know this already, so just answering this as fast as we can. Okay, so number 4. So yeah, number 4 is we have to use our oh, maybe, diba? So we have to use an equation from Paris. Diba? So this is equation 11-1 23. Okay, so you will find this at BPR is equal to 149.4.9 and N2 1.14. So what is N2? So N2 is the sum of the molar fraction of these. Okay, so if you add that, then you will get N2. Okay, so one that, then if you add all of them, you have 0.43 and then raised to 1.14, and then you will get 40. Okay, so we are asked of the boiling point, so just add to the original boiling point of water, which is 212 degrees Celsius, diba? So plus 40, you have 252 degrees Fahrenheit, and that is letter C. Okay, number 5. So heat transfer device is normally used to liquefy vapors. Liquefying vapors so from gas to liquid. So that's a condenser. Number 6. Country where capital is scarce and energy cost is low. So more appropriate to install single effect, diba? because I don't have much money. So the evaporation operation, the valuable product is called, yeah, that's thick liquor. Number 8, same duty and heat transfer area. Feed forward flow evaporator is blank compared to the backward flow evaporator in terms of heat transfer. So why are we choosing between the two? Because one is more effective. And okay, so is forward feed more effective than backward feed, or vice versa, or the other way around? Okay, so um, actually feed forward flow is less efficient than backward flow. Okay, in terms of heat transfer. Uh, so if you can see, as you move on to the evaporator or the heat exchanger, diba? We favor uh, counter current flow. Why? Because the heat transfer area will be lower. Okay, so meaning the heat transfer is more effective in the counter flow than the co-current flow. Okay, so we can see that, or maybe you have observed that where you were while you were solving. Okay, so actually observed that in in the time that I was reviewing. Okay, so I can tell you that with confidence. Okay, number 9. So temperature driving force in an evaporator is determined as the difference between the condensing steam temperature and, so meaning the temperature driving force. This is the condensing steam minus the, actually this is the sum of the BPR, yeah, and also napog kay temperature of the last effect ng evaporator. But for this, boiling point of the solution lang siya. Boiling point of the solution, which is kini. But if we don't have BPR, so kini siya, which is, this is the boiling point of the solution na kiniti, or the last effect, or if the effect, you only have one effect, so kana siya, the boiling point of that. Okay, so yeah, if you if you account for BPR, diba? This is the boiling point na siya, boiling point rise. So that's the new boiling point of the solution because it has been added with boiling point rise. Yeah, if you know what I mean. Okay, so number 10. So yeah, number 10, we have to please read it na lang. So I'll provide the solution here. So yun siya. So, imagine this is your evaporator. Okay, so this is your evaporator. So you have the inside is 5 psia, diba? 5 psia. And then we have steam here, so S. And then you have our feed, don't know yet, the feed rate, and then we know the temperature, which is 98 degrees Fahrenheit, and we know its concentration, 7%, 0.07. Then we have our vapor here, which is 1.5 pound. And you have your liquor, your thick liquor, don't know yet, but we are concentrating it to 18%. Yeah, diba? 7 to 8% of concentration. So what we will do here is that we will do the overall material balance, which is just the feed is equal to vapor plus the thick liquor, diba? Thick liquor, and then we have this, diba? 1.5. Okay, so we have also our component material balance. So FXF is equal to LXL. So this is the assumption that no entrainment is happening, diba? Entrainment is when the solid natin dito Okay, so it goes with the vapor. So we are assuming that no solid is evaporated. Okay, so that's just water or the solvent. Okay, so yan. So let's see what we can get here, diba? So we don't know F and 0.18L, diba? 0. So I just substituted it here and then transpose it to the other side. So you can solve simultaneously now. So F is 2.45 pounds and you have L 0.95 pound. Okay, yeah, that's nothing too difficult for this to understand. Okay, so we have our 5 psia na pressure, diba? So just multiply it by 6894.8 and then you can get the pascals na tayo. So this is the uh, conversion factor from psi to pascal. Okay, so pascals, and then you have the temperature of the evaporator, ba? So from this you can get here, you can get it in the steam table, table 2-305. You can get there in this pressure, absolute pressure, you can get the saturation temperature. Okay, so this is 72 degrees Celsius for 161.6 degrees Fahrenheit. Yeah? So we are asked for, we are asked for the heat, the heat that is required to evaporate 1.5 pounds of water. So we get here Q, Q mcp delta T plus the evaporated na evaporated na liquid or the vapor na, then times the latent heat of evaporation. Okay, so we know that our feed here is about 2.45, 2.45, and then we have a CP of water of 1 BTU per pound per degrees Fahrenheit, and then we have 161.6 minus the temperature of the feed, so 98, plus the vapor, which is 1.5, and then we have the latent heat of evaporation. So this is what I have memorized, 540 cal per gram. Okay, cal per gram. So transform that to BTU per LBM. So you will have 972.93 BTU per pound mass. Then you can get 1615 BTU. Yeah. Okay. That's letter A. That's the nearest. Okay. It's the nearest of them. Letter A. Now let's move on to number 11. So if the overall heat transfer, so this is the U, diba? U is 200 daw kuno. The temperature driving force, so T is equal to 90. The heating area in square feet to process 1,000 pounds per hour of feed is what? Okay, so we have to find that. Now, what will be our solution? Okay, don't forget that Q is equal to A and M. Okay, this is another form of that, diba? So, and we also have the steam or the kining the Q, diba? We have the Q kanina, but this is the Cp delta T, diba? Plus V, then latent heat of evaporation. Okay, so let's do another overall material balance. Okay, so we have um, FXF equal to LXL. So we have 1000 here, 0.07, and then we have L, then 0.18. You will get L to be 389 pounds per hour. So meaning V is equal to 611 pounds per hour. Diba? Pounds per hour. So we now have to put it in this equation. Ini siya. Diba? So we have A is equal to ini. So we have 1000, then 1, then we have 161.698. This is 90 plus 611, and then 172.93. And then we have 200 times 90. Okay, let's get the answer. Okay, so 1000 times 3 plus 611 times 73, 200 times 90. Hey, I made a mistake here, diba? So this is not 1616 because we are given the I, the diba? Temperature difference. So kini delta T, and these are the same. So 90 po din siya diri ubos, and plus 611 times 172.93. So you have 38 square feet. Yeah, that's letter C. Yeah. So number 12. So kini siya, number 12 is I don't know how to solve this, but I got this by linear regression. Okay, linear regression, and so mode 3 2, yeah, mode stat then 2, and then x is the time, so x then y, so time siya dire, time, and then the u, so this is tu, then u din na siya, and then you can get so at the time 0, diba, or at the beginning of time, you can get what closer value to letter B, 600. So that's what I did. I really have no concrete solution that I can give you. That's how I solved this problem. Okay, number 13. So number 13 to 15, they are really quite challenging. Okay, this is a quite challenging problem. Okay, so let's solve this. I'll leave the reading to you. Okay, so number 13, number 13. So this is number 13. We have a single effect evaporator. Okay, a single effect evaporator. We have steam here. We have our feed. So let me write all the answer given. Okay. So the values, they ay kining HV, di ba? HV. So you have HV here. So HV, which is the enthalpy of the vapor, di ba? At this temperature, at kining temperature 58.74 degrees Celsius. Kini dayang pressure is, di ba? 61.67 centimeters mercury na vacuum. So meaning you have to uh, subtract that from the atmospheric atmospheric pressure, which is 760 millimeters mercury. So you will have 143.3 millimeters mercury, and then convert that to kPa. You have 19 kPa, and then you can find the value of your um, enthalpy at that temperature, which is 2000 in 2605.94. Okay, so that's how I got those values. That's get it from the steam table. If you don't know how to get it from the steam table, I will post the video here at the upper right hand corner of the screen. Yeah? So I made a video on how to use the steam table. Okay, so you have HS. Okay, so HS, this is still from the steam table, EG, and then this is for the latent heat, or the enthalpy of the liquid, gamay nga H, so small h. This is for the liquid, diba? For 83.94 kilojoules per kilogram. Okay, so we have also our HF at this temperature, 25 degrees Celsius. So this is liquid man. So dito sa liquid, saturated liquid, magkuha. Yan. Okay, so let's do our overall material balance. We have F minus L is equal to 9,000, and then we have our CMB, component material balance, be 20F minus 0.65L equals 0. So solve simultaneously, you can get this is 13,000 kilograms per hour, and then you have L, 4,000 kilograms per hour. Then we have to have our overall heat balance. Okay, so overall heat balance. Okay, so what goes in and what comes out? Okay, so we have our F, diba? So we have our F, HF plus our S, diba? Our steam. We have our latent heat of evaporation, H minus HS, and then you have V, diba? HV, and LHL. Okay, LHL. But where do we get our HL? Still from the steam table. Okay, so we have HL, diba? HL at this temperature yapon 58.74. The sa liquid nga part, diba? Liquid nga part, you have 245.85 kilojoules per kilogram. So substitute everything here. Okay, substitute everything, diba, that you got. So you can see you have 10,424 kilograms per hour nga steam. Number 13, you have letter C. Okay, so number 14, In number 14, so we are to find the area, di ba? We have to find the area. So area is equal to Q, di ba? Q is equal to U na. But we know Q, di ba? From this heat balance, ini lang, ano siya? Ano? Can get that. So, Q, ano na lang, ako na lang isulat na, yeah, equal to, yan, yan na. So, hover is, yan, then you have our U, yan na. Okay, so you have a 10,000 of 424, but this is kilograms per hour. And then you have your latent heat of evaporation. Yeah, so it just subtracted it already, 2214.4 over, this is a little conversion factor, 3.6. Okay, then we have 1800, diba, our U, and then you have our delta T, 58.74. Okay, so remember that this is kini siya minus ani, wala siya ang ato ang delta T. Okay, you will have 63 square meters. And then lastly, number 15, we are required to steam economy, diba? So number 15, so SE. So this is just simple. You have your V is over S, okay? V over S. This just diba? 9,000 over 10,424. Can get a 0.863. Okay, that's letter B. Okay, then this is letter B also. Okay, so yeah, and actually I will end this video here. Okay, this is getting long already, so we have 10 more items left, and that last 10 items are somewhat very hard. Okay, so I want you to brace yourself for that, and I hope you enjoyed this evaporation video. Okay, and I hope to see you in the next one. Okay, bye bye.